All right, guys, welcome to the continuation of operations with scientific notation. And today in this video, I'm going to re-explain problem number 2 on page 50, which was multiplying scientific notation. And then I am also going to go over the exercise that has to do with adding, or excuse me, with dividing scientific notation. So I'm getting rid of this, and just because I was doing a little bit of a practice run before I started. Anyway, if we go to page 50, on page 50, specifically problem number 2, they're talking to us about 5.23 times 10 to the power of 6 micrometers, and they want us to multiply that by 7.1 times 10 to the negative 2 micrometers. So one thing that you want to take into account is that when we're multiplying or dividing scientific notation, it doesn't really matter if the exponents are different. What matters is that the base is the same. And in this case, the base is the times 10. And because times 10 is present in both of them, of course, because they're in scientific notation, I'm going to go ahead and move the times 10 part to my answer. And then whenever we're multiplying exponents, we add them algebraically. So we have 6 plus negative 2, and 6 plus negative 2 is actually positive 4. So I know that's going to be times 10 to the power of 4. Now, another thing that we're doing is we're not just multiplying the numbers. So we're not just multiplying 5.23 times 10 to the power of 6 micrometers and 7.1 times 10 to the negative 2 micrometers, but we're also multiplying the units, which means we're multiplying the micrometers times the micrometers. And that's why you see that in your book, the answer says micrometers squared, because you have 2 units that have a micrometer measurement and you're multiplying them. Now, the next thing we're going to do, and you can use a calculator or do it manually, is we're going to multiply 5.23 times 7.1. If you multiply 5.23 times 7.1, your answer is 37.133. And technically, you would say, well, then that's it. That's my answer. I don't need to do anything with it. The problem is done. But we're working with measurements. And scientists use these measurements to try to have a more accurate answer, or to try to have a number that's workable, which means that we have to apply the rules of significant figures. So that means that if I look at 5.23, I have 3 significant figures. And if I look at 7.1, I have 2 significant figures, which means that according to the rule, I'm going to leave my answer rounded to the same amount of significant figures, in this case as 7.1, because again, 7.1 has 2 significant figures and 5.23 has 3 significant figures. Okay, so because this one has 3 significant figures and this one has 2, I'm going to leave it expressed at 2 significant figures. Now, if I look at 37.133, I have 5, and I only need 2. So the first thing I'm going to do is move my decimal. Now, if I move my decimal point, in this case, I'm moving it from right to left, so I can have 2 significant figures. 3 point. Now, I want to make sure that the number that I have next to the 7, I want to know if I have to round that up or round it down. Now, if I look at the 7, the number next to it is a 1. And that means I round down, it stays the same. It doesn't change. So this would be 3.7. Now, what I was going to get at, whenever I move my decimal point from right to left, that means there's going to be a change in the exponent. And if I'm moving my decimal point from right to left, that means that to this exponent, I'm going to add 1, because I'm going from right to left. So that would mean that my final answer for this problem is going to be 3.7 times 10 to the power of 5, because I only need 2 significant digits and I move my decimal point from right to left. So that means I add a decimal place, so to speak, and that would be times 10 to the power of 5, and of course micrometers squared. And that's pretty much it for that one. Now let's look at the second problem on that same page. And in the second problem, we are dividing. And we're actually dividing 5.44 times 10 to the power of 7 grams. Let me see if I can use a different color and hopefully be able to illustrate it here at the bottom, so that way you have both problems as your reference. So I'm dividing 5.44 times 10 to the power of 7 grams. 5.44, okay, times 10 to the power of 7 times 10 to the power of 7 grams over 8.1 times 10 to the power of 4 moles. 8.1 times 10 to the power of 4 moles. And moles is a unit that we're going to see a little bit later on. That's used in analytical chemistry. And but that being said, let's just go on and look at the problem. So I have this in scientific notation. Now, however, I'm dividing. Now, when you're dividing, it follows pretty much the same rules as multiplying, in the sense that it doesn't matter that the exponents are negative as long as the base is the same. And the base is the same because it's times 10 and times 10. So I know that that's going to be part of my answer, and I'm going to say times 10. Now, whenever you are dividing exponents that have the same base as they do in this case, you subtract. So you're going to subtract 7 minus 4, which is 3. And the next thing you're going to do is you're going to divide 5.44 by 5.44 by 8.1. And you're going to get a pretty big number. So 5.44 divided by 8.1. And you're going to get 0.6716. So you get a pretty big number. You're going to get 0.6716. Let's see if I can have the space to write that number down. 0.6714 I'm sorry, 16, not 14. 0.6716. 0.671604. 1604. 167 0.671604 9383 9383 83 9383. Okay, times 10 to the power of 3 grams over moles. Now, we're going to apply the same rules that we did here. It's just that when you're dividing, so when you're multiplying, you multiply in the units, but you're dividing, and because the units are not necessarily the same ones, we just leave it expressed as grams over moles, or G over moles in this case. So what I need to do to finalize my problem is to apply the rules of significant figures that we have been using. So again, 5.44 has 3 significant figures. Let me change colors. Let me use black. So 5.44 has 1, 2, 3 significant figures. and 8.1 has 2. So that means that I am going to move or make my answer have the same amount of significant digits as um, the number with the least amount of significant figures. So this one has 3, this one has 2. That means my answer has to have 2 significant figures. So that means I have to move my decimal point again. But notice how in this case, because I'm dividing, I got a smaller number. And I have to move my decimal place to the right in this case. And the reason I have to move it to the right is because I want to have 2 significant figures and I want to write in scientific notation. So that means that my decimal point in this case has to be between the 6 and the 7. But before I do that, I want to make sure I round correctly. So I know that I need 2 significant figures. I know that after the 7, there's a number. So I'm going to look at the number after the 7, and the number is a 1, which means I don't have to round up. I just leave it expressed or leave it the same or round down. And what you're going to have is then 6.7. Now notice that when I move my decimal place in the previous example from right to left, I added 1 in this case to the exponent, and that gave me 10 to the power of 5. In this case, I was moving from right to left, so I added 1. In this case, I'm moving from left to right, so that means I subtract 1, which means I'm going to take away a decimal point or a decimal place, and you're going to subtract 3 minus 1, and that's going to be 2, so your final answer is going to be 6.7 times 10 to the power of 2 grams over mole. Grams over mole. Grams over mole. 6.7 times 10 to the power of 2 grams over moles. All right. So this is a review of what we did today in terms of multiplying and dividing measurements in scientific notation. Hopefully this is useful to you guys. I already assigned the practice problems for today. So stay safe, and until we see each other in our next class. Bye.